Okay, let's begin. I think we're set up okay. So we're just going to go through the examples that I emailed you guys. Hopefully you guys try them on your own, because just watching me do them is not going to do you much good. You need to know that you can do them. So we're just going to do some derivative examples. Maybe after looking over these, you can look over the quiz again that I just gave, and things will be a little bit more clear. It's not going to be sad. You're learning new knowledge. It's not sad. Okay, so let's just start from the beginning. I don't remember if we did a couple of these before anyways. Let's do that one. How would we do that one? Yeah?
How we would apply the product rule?
Product rule. You see a multiplication of two functions here. So you apply the product rule. Think of one as f, the other as g. What does the product rule say?
F of x times f prime, the derivative of g of x plus g of x times the derivative of f x.
Sure. Differentiate one at a time, add them together. I probably memorizing the way where the f prime comes first to carry over to the quotient rule. But that's basically it. Yeah, you differentiate one at a time, you add them together. So this guy is going to end up being derivative of this. 3x squared by the power rule, leave the e to the x alone, plus, now you leave the x cubed alone, derivative of e to the x, e to the x. That's good enough for now. You could factor this if you wanted to, so like an x squared e to the x could come out, left with 3 plus x. But at the moment, let's not worry about that. There will come a time when we'll want to set the derivative equal to 0, and I'll talk about those contexts. And in those contexts, factoring is definitely something you're going to want to do, but at this point, something like this is okay. On to the second example. Square root of x times e to the x. How do you do that? Same product rule. One function, that's your f, times the other function, that's your g. So it's the derivative of this, which is what? 1 over 2 radical x times that one, plus, now we leave this one alone, differentiate that one, which is just that. Or, if you forgot the fact that radical x, the derivative of radical x is 1 over 2 radical x, you could actually just derive this from scratch from the power rule by just rewriting that guy as x to the 1/2. And then just applying the power rule to this guy, you can get the 1/2 this to the minus 1/2 plus. And that's, either one is fine. What if we're looking at the derivative of 3x squared times ln x? How do you differentiate that one? It's the product rule again. So this times that. Derivative of 3x squared is? 6x. Plus now when I leave 3x squared alone, derivative of ln x? 1 over x. Here these guys can cancel, so I have 6x ln x plus 3x. And that's good enough at this point, but you could also factor out a 3 to ln x plus 1. Factor out a 3x would also be an option. So are my answers lining up with your answers so far? Okay, good. If they don't, you should ask a question so we can clear up any misunderstandings. Kind of running through these quick because again I expected you guys to like work on these before. How'd you do that one? So you could do the product rule. And so differentiate this, it's 1, leave the radical x, plus now you leave this, differentiate the radical x, you get 1 over 2 radical x. This you'd be able to cancel into that. So you have radical x plus a half radical x, or it'd be 3 over 2 radical x. There's another way, perhaps a preferable way. What's another way we could have done this? Yeah?
Like use power rule, not power, like x, radical x could be like x to the 1/2.
So you think of this as x times x to the 1/2, and then what?
And then like combine them and you get x 3 over 2, I think.
And then you just use the power rule. And you get the same thing. Okay. So, the moral of the story here is sometimes it will be beneficial. I mean, this example isn't crazy. You won't see the full benefits on something like this, but there are other cases where the benefits really start to show up. A recommendation is to try to simplify not only after you take a derivative, but before you take a derivative. Right? There's so many times where that will be so much easier. Even on the quiz that I just gave you guys today, if you focus on simplifying before, a lot of the problems became a lot easier. Which, I mean, collecting them, I already saw some people just really killing themselves trying to figure stuff out. Like in problem 3, I asked you to simplify something with an ln, and then in problem 4, I asked you to differentiate the exact same function. I expected you to use the fact that you simplified it and just find the derivative of that. You wouldn't need this huge, humongous quotient rule with like things all over the page, like written, it run into the other questions. Like you didn't need that. You just used the simplified version. Differentiating each part of that was like super easy, but whatever. I digress. So,
Can we go over 3?
Yeah.
so you're like ln of this huge thing, you're like, okay, derivative of the top. And you did this whole quotient rule divided by the bottom. I'm like,
Can we go
Wait,
over
can we
fine,
go
you
over
just
it?
simplify.
Can we go over it? Please?
No.
We didn't do 4A. We didn't do 4A.
I mean, I want to get through these. Don't have time for this. Don't have time. So, where was this? Yeah, so in problem, like there was problem 3 on the quiz where I said, simplify this. Well, how did you simplify that?
Well, the problem before was the one where you had to wait, is the simplification or
Yeah,
derivative?
simplify. This is simplify.
So then, yeah, I did ln of the top minus ln of the bottom.
Sure. So that you started there. Alright, because that's log of A over B is the same as log A minus log B.
And then I did ln of square root of x plus ln of x plus 1. And all of that in parentheses. And then minus parentheses ln of x squared plus ln of dx, which is just x.
Okay. And then what?
Ln of the square root of x is x to the 1/2.
Right, so you can rewrite the square root as x to the 1/2, and then
I brought that half down as a coefficient.
there's another rule that says you can bring that down. There's a rule that says I can bring this square down as well. And then ln of e to the x is just x. You could go one step further and combine these two. And so we have minus 2 plus a half. It's minus 3 halves. Right? So that would have been answer to 3. Now having done that, the answer to 4 part A would be a lot easier. You went through all the work to simplify that. So now if I come and I'm like, okay, differentiate this guy. Now we know the rule for differentiating ln of something. It's the derivative of the thing divided by the thing itself. Now if you're taking the derivative of this, that's not going to be fun. You're going to have to do the quotient rule with the product rule inside of it. It's not going to be a fun time. But in the previous question, you know that this guy is the same as that guy. So the derivative of this is just the derivative of that. And each of those are pretty easy to differentiate. Derivative of sum is just sum of derivatives. How do you differentiate this guy?
ln of x, the derivative of that is 1 over
3
x.
1 over x, and you leave the constant alone. That's a constant factor. So that's just 1 over 2x
It's not
plus.
negative.
It's negative 3x.
Negative 3x. X.
What?
What?
Come again?
It's negative 3.
It's not just
Oh,
3 halves.
okay.
Oh, negative. Okay. Okay, because I'm like, where did the negative 3 go? Okay, yeah. That was negative for me. Okay, so now derivative of that.
1 over x plus 1.
Times the derivative is 1, derivative of that is minus 1. So that's your answer. Moral of the story, try to simplify before you take derivatives. Every time you want to differentiate something, don't just run into a sophisticated rule. Oh, quotient rule, just because there's a division. Or, oh, there's a log, u prime over u. These rules are true and they will work out, but sometimes it's to your benefit to simplify first. So if I saw that x radical x, I wouldn't do the product rule. That seems to be overkill. Just rewrite it as x to the 3 over 2 and do the power rule. Always try to get away with doing the simplest thing possible. The power rule is pretty much one of the simplest derivative rules around. So if you can use that, you should. Okay, let's get back on track here. And a lot of derivatives, a lot of these guys were like that. Okay, let's look at x squared plus 1. What about this one? This was also on the quiz. Derivative of x squared plus 1 over x squared. How did you guys do that? Yeah?
Is it like x, since x squared and x squared cancel out, and then 1 over x squared, you would make it x minus 2 and then do power rule? Or no? I don't know.
Is that okay? Can these cancel?
No.
No, you cannot cancel across sum, so that's not right. But you can break a fraction up in terms of over the denominator, right? So that's true. So this is really just the derivative of 1 plus x to the minus 2. And so derivative of that is 0, derivative of this would be minus 2x to the minus 3. Did the quotient rule, it would have been a lot nastier. Anyway, moving on. What problem are we? 5. How do you differentiate x plus 1 over x plus 2? How did you guys do it? You're like thinking, can that simplify this? It can't really simplify, so what do you want to do? Just use the quotient rule, because you can't factor and cancel anything here. That's an x plus 1, that's an x plus 2. What are you going to do? So this guy here is your f, that guy here is your g. I could break that into 2 fractions, but I don't think it's worth it here. Because it's not something you can see immediately. So how do we differentiate something like that? What is the derivative of a one function divided by another? Over g squared, right? That's something you have to memorize. That's called the quotient rule. So I'm going to apply that here. So derivative of f is 1 times the g, so that's x plus 2, minus the f, which is x plus 1, times the derivative of the g, which is 1, over the g squared. Order matters here. If you did it in the wrong order, you would get the wrong answer. We can simplify this a little bit. This is x minus x, 2 minus 1. So that just becomes 1 over x plus 2 squared. Which kind of makes sense, because technically you could simplify this to 1 plus 1 over x plus 2. But well, minus. But yeah, I wouldn't worry about that. That's something you need to practice to see, I think. What about this one? 6. The derivative of x squared over 2. Yeah?
Do you just, I don't know, do the top part and leave the bottom alone?
Ignore the denominator. We spoke about this last time. You do not need to apply the quotient rule whether the top or the denominator is a constant. In the case that the denominator is a constant, you literally just leave it alone. So that's x. I think there are also problems on the quiz where I put like a number in the denominator. So if you did the quotient rule on that, you wasted a lot of time. Just leave it alone. Differentiate the top. What about 7? What is the derivative of 3 over radical x? Yeah?
Could you rewrite it as like 3 times x to the negative 1/2?
I would. So this is 3 times x to the minus 1/2 wouldn't go through quotient rule. And so negative 1/2 comes down, subtract 1 from the power. So that's your answer. You could do the quotient rule. It's overkill, and you'd also have to remember that the derivative of 3 is actually 0. So when you're doing the f prime, it actually kills that term. For some reason though, I always find that students often forget that. When they're applying the quotient rule, they forget that when they're differentiating a constant, they put 0, and they just rewrite a constant and get something wrong. 8 is very similar, so I'm not really gonna. It is 4 over x cubed. So again, I would just rewrite this guy as 4x to the minus 3. Do the power rule, constant factor rule, leave the 4 alone, so the minus 3 comes down, multiplies that. Subtract 1 from the power. That's problem 8. Problem 9. Okay, how do we do that one? Do the quotient, right? Can't really simplify anything, so just jump to this quotient rule here. So that's my f, that's my g. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And I could simplify this. There's a common e to the x. Take that out. This cancels that. This is 1 over x minus ln x over e to the x. If this were a problem in your textbook, that's probably not the way they would put it in the answers. They probably want to simplify the complex fraction, so they multiply by x over x. And so you get 1 minus x ln x over x e to the x. But personally, I wouldn't care about it. Here's a question just to make sure. How would you rewrite that without parentheses? What's e to the x squared? You should know that this is e to the 2x, right? It's not e to the x with the square. It's not if you were thinking that, that's not the right way to go. Because right, when you raise one thing to a power to another power, you multiply the powers. Laws of exponents still work. Let's move on, problem 10. Have you guys been getting all of these so far? Well, sure. Sure, yeah. Okay. What happens here? So the product rule, that's your F, that's your G. Derivative of this, leave that. Plus, leave this, find derivative of that. Again, I could factor out a common e to the x if I were so inclined. Usually I wouldn't be, but it's not hard to simplify that here. How would I do that one? Yeah? Need the chain rule. Okay. Why? Because there's an inside function, right? The closest thing to this that's very simple is just x by itself to the 20, and we could use the product rule. But instead of the x, there's a function. So this really applies to the chain rule when we have an inside function. So this guy here is your inside function. It's plugged into a power function. So we need to apply the chain rule. What does the chain rule say? Yeah?
Take the derivative of the outside, keeping the one of the inside, and then
Well,
times
the derivative of g of x is the derivative of the outside times derivative of the inside. Right? So that's the rule we're going to apply. I mean, this part of the answer I usually give you in the quiz and then you fill in the blank here, but it's important that you remember a rule in its entirety. So also memorize the left side as well. Including the d dx. Don't neglect to write it. Write everything out completely all the time. There's a very important psychological reason for why you need to do that. But we'll probably discuss that some other time. Okay, so let's apply that here. So I would differentiate the outer function, which is the 20th power, and bring that down. Leave the inside intact. Then I want to multiply by the derivative of the inside. So this will give me 3x squared using the power rule. Notice I put parentheses here, even though it's not necessary. Probably you want to get into the habit of writing the parentheses. Because if there are several terms in the derivative, they each have to multiply. You have to follow the distributive law. So parentheses. They're kind of redundant here, but it's better to have them there and not need them than to not have them when you need them. One thing you could also do, you can multiply this 3x squared by the 20. So you'd have 60x squared times x cubed plus 1 to the 19. One thing you do not want to do, just to kind of preemptively nip this in the bud, do not multiply x squared into the parentheses. That is not something that you can do, right? You can't take this 3x squared and multiply inside here, right? So you can't write this as 3x to the 5th plus 3x squared to the 19th, right? That will not work. Just want to make sure that no one even had the thought of doing that. The reason is because this doesn't have the 19th power, you can't bring it inside because there's a law of exponents. You know that. The only time I can bring something and put it together with this and raise it to the same power is if it individually had that power as well. The rule does not work like this. So it's not going to work like that because that 19th power, this guy doesn't have it. Right? So you can't multiply in because you violate the laws of exponents. So you can take this and multiply the thing in front. You cannot multiply the things inside the parentheses. Several people made that mistake when trying to simplify 1b on the last test. They started multiplying into these guys when they had like the 8th power or something. You can't do that. How do you do that one? Yeah?
Use the chain.
Use the chain rule? What rule are you thinking of here?
Well, I guess you could think of it as like, you take its e, it would be e to the x to the third plus 1 times the derivative of x to the 2.
Could you split it up as e to the x cubed times e to the 1? Would that even?
You could, but would
I don't
that
know, would take for you.
would that be necessary? What is the rule that you're thinking? Can you write down the rule that you're trying to apply here?
Yeah.
Yeah?
Is it like
I
e?
Yeah?
Is it e to the u times a derivative of u? No.
Well, I want you to tell me the rule. So the rule is the derivative of e to the u is u prime e to the u. So that's what you are applying here, where this is the u.
Yeah.
Right? So the importance of the rules and knowing and memorizing them in its entirety, one thing is that you want to be able to take that rule and fit it on top of your thing, kind of like a template. Right? That's one reason why you want to memorize something in its entirety. So you can see this guy here as a u, just like in that rule. And so the rule says whenever that happens, this expression becomes that expression. So you take the derivative of the power times the original function. So the derivative of the power would be 3x squared by the power. Right, so that's the rule. Another thing why you want to memorize rules in its entirety. I kind of mentioned this in my other class, so I guess I'll mention it here. So this is one that I see a lot. I don't really see it here a lot, but the fact that the derivative of ln x is, what is the derivative? It's 1 over x. Right? Now sometimes I see this on tests where students write their little formulas, you know, they regurgitate their formulas on the front page so that they don't remember, they don't forget, right? Now there's a good reason for doing that because they know that when they start in a test and they start getting anxious, they're not going to remember things properly. So they're like, let me just write down all my formulas right now at the beginning of the test when I'm calm, and then I'll go through the test. So that's like a strategy. It's a good strategy. The problem is they don't follow through the strategy well enough, because sometimes I'll see them get sloppy and they'll do something like this and they'll not write that. Right? So they'll just like, you know, and in their heads they tell themselves, yeah, I know it's the derivative of x is 1 over x, but they don't actually write that down. And so the strategy can backfire because ever so often I see in these tests where they literally take an ln x and they replace it with 1 over x for literally no reason. Like there was no derivative, I'm just talking about ln x, and they just like, you know, and so there'd be where they get to a final answer, and let's say the answer is ln of 2. They'd go an extra step and write a half. For no reason. And the reason why is because they don't remember that. The idea is you need this in front of an ln to become even something like that. This wouldn't work anyway, because this is a constant derivative, would be 0. But not remembering rules in its entirety, when you do get anxious, your brain will dump the fact that the thing you're not writing is supposed to be there, that you remember it's there. You're not going to remember. It's the same idea when not putting parentheses even though, yeah, I know it's supposed to be there. The same thing will happen to you with the rules. You'll start realizing that you're going to be applying rules for no reason. And they'd come to me and they're like, I don't know why I did that, Jhevon. I know better than that. That's why you did that, okay? Partially memorizing rules is why something like that happens. And that's why a lot of times students will be like, I really studied, I worked hard, and they don't do that well. It's because they're not studying in the right way. When you memorize a rule, memorize it in its entirety, memorize it to the point that you know it well enough to be able to look at it as like a template. This is a template. That you can plug in anything for that U and it will apply. That's how you want to think. It has to fit right on top of the thing that you're looking at. And if there's anything in this thing that doesn't look like that, you cannot apply that rule. So if you have something like, you know, E, and then there's a 2 to the x cubed plus 1, right? Suddenly this rule doesn't apply anymore. It's not like, oh, there's an E and there's something up here so I can do this. No, it doesn't apply anymore. Because there's a number here that's not here. See what I'm saying? The rules are templates. Memorize them in their entirety because they need to fit right on top of any problem you're doing. As well as you don't want your brain just like randomly doing things when you get anxious, right? Because your brain, whenever you get anxious, your brain is going to get rid of these higher level brain functions. It's not going to be able to do a math problem and remember that there's something supposed to be there when you didn't write it down. So these things happen. Don't let it happen to you. Okay. Okay, so where are we? 13. How do I differentiate that?
Yes, just 1 over the polynomial, or 1 over the whole thing.
No. What's the rule we'd apply?
Oh, chain rule.
You need the chain rule, so what rule is it? Yeah? What's the rule? Yeah? Yeah?
Is it differential ln
Derivative?
Yeah, of ln u equals to u prime over u.
That's the rule we're looking at here. Because it's not just literally an x. There's an entire thing here that's not just an x. So this whole thing I would think of as u. So this fits on top of that and like, okay, this is in the position of u, that's going to be my answer. So I'm going to take the derivative of this and divide it by itself. What's the derivative of this?
3x squared plus 2.
Right, use the power rule. So that would be the answer. So it's not just 1 over, you have to remember to multiply by u prime because of this rule, because of the chain. So the other rule was just 1 over. This happens when there's literally just an x, right? So this doesn't fit with that. The template wouldn't work because that's an x and this is a bunch of things being added together. It doesn't fit on top of that. This guy though, my x is here, my u is obviously something other than x. So this is a generalized version of the rule. So this guy could function as a u. So this rule doesn't really apply to that. This is the rule I would apply to that, right? Because that the template fits. What about 14? The derivative. How would I do that? Okay, how would you apply the chain?
It would be 1 over 2 brackets
You said 1 over what?
1 over 2 radical 2 minus x squared.
Okay.
Times negative 2x.
Yeah, that'd be right. So this is just her remember that the derivative of radical x is 1 over 2 radical x. Again, if you forgot that, you could have just rewritten it first to say that this is 2 minus x squared to the 1/2. And so then you can bring that half down. multiply by the derivative of the inside because of the chain rule, and you get exactly the same thing. These two are both the same. This, if you bring it underneath, you get that. The 2's can cancel. Similarly, they can cancel here, so I can have minus x over the radical of 2 minus x squared. Or in this case, I would have minus x times 2 minus x squared to the minus a half. Either expression is acceptable to me. A lot of students are sloppy with the rules, but there are some things. It's so funny. The things that you can like not care about are the things that students remember. Like this, oh my god, there's a negative in the power. Like I have to rewrite. You don't have to. There's nothing wrong with this expression. That's just like something your professor told you in algebra class just to mess with you, just to keep you busy so you don't like bother. Right? There's nothing wrong with negative power. There's no reason to rewrite this as that. I don't care. Negative powers are fine in your answer. Which kind of reminds me, that was something that happened in the test. I don't know if I mentioned this. But in the test there was an answer that was similar to like 5 minus e to the minus 3 over 2 or something similar. And seeing that negative power freaked some people out till they had to get rid of it. And then they just did like, I'm not sure what happened. They literally just like, okay, let's just take this guy and move it underneath. And so it became this. What? No, that is not true. You cannot do that. There's a sum here. So just because you're freaking out about a rule, that's not actually a rule. Like there's nothing wrong with writing a negative power. You totally like just mess everything up. Like you can't do that because of the sum. Right? Moving this e down is equivalent to you multiplying and dividing by e cubed. You're simplifying a complex fraction here. Really what you have is 1 over e cubed over 2. You want to get rid of this guy, you have to multiply by e cubed over e cubed. That's how the e cubed becomes in the bottom. But then you have to distribute. So the 5 doesn't just not get there and this guy disappears. This will become a 1. That will become a 5e cubed. So if you didn't like the negative power, the right thing to do is this. Where that came from, I don't know what was going on. But I think you were freaked out by the negative power and people just tried to get rid of it. That's not a thing that you have to worry about. Of all the things to remember in algebra class, you remember that? It's not even a real rule. Like, calm down. Negative powers are fine. Radicals in a denominator are fine. In calculus, we don't care. We're beyond that. Don't freak out and end up doing something wrong because you're trying to maintain some sort of standard. Okay. Let's move on. How do we do that one? How do we do that one? We're all excited over the snow day?
Yeah.
I have one
They already announced See, I have mixed feelings about that. This is one of the things in being a teacher. Like, there's so many things that now I'm like pulled both ways. Because on one hand, I want a snow day, so I want to be here. But on the other hand, I have to teach classes. I have classes to teach tomorrow. So now I'm like, now I'm gonna have to make that up somehow. Where am I gonna find a whole extra lecture? It's gonna just like mess everything up. So it's like it's bittersweet for me. Now, in my other class where I wanted to be on Friday, I will no longer be there. One of my classes is supposed to have a quiz tomorrow, so now that's going to get pushed to some other time.
I'm sure they'll be devastated.
Yeah, because now then by the next time I get it, I can't put all the material for that quiz and the other quiz. That would be a monster quiz. That's not going to be good.
Just do it.
Where am I going to fit that extra quiz?
Just Just give us one quiz and then give us 100 for the other way.
I'll console myself by sleeping in tomorrow. Going to my
Go hard on the
Do it.
I'm like, yes, no, screw this, let's get out of here. Like, we're not even here. Yeah, see, my brain is just like, yeah. We'll make this up soon. Yeah, let's do this one and get out of here. 'Cause I mean, that's totally like killed my motivation just now. Quotient rule. So bottom times the derivative of the top minus the top times the derivative of the bottom. How do I find derivative of the bottom?
Power rule.
Not exactly.
Chain
Rule. There's not just an x, so the 16 comes down, you leave the inside alone, subtract 1 from the power. Derivative of the inside happens to be 1, but you should know that it should be there. Over the bottom squared. What's x plus 4 to the 16 squared? Right, power would be a 32. Right, you double the power. And then what you can do is here you can simplify. So we can factor out x plus 4 is a common term. So let's take that out. I can take out to the 15th power. In here I'll have an x plus 4 left over. Minus here I'll have that 16 left, the x plus 1 left. This guy I factored out. This cancels that. On the inside here I have x plus 4 minus 16x minus 16. And so I would simplify that. Alright, calm down. And that would be your answer. We'll stop there because we're out of time anyway. We'll pick up on Friday.